Hello, welcome, Algebra 2, A7, function composition. I'm closing the door because I have to talk really loud, it seems. Function composition. Here we are. So with your numbers, you have four operations. When we are using functions as our mathematical playthings, remember last week we did function operations. You added, subtracted, multiplied, and divided two functions and got a new function. And this is another operation, a new one. It is called function composition, and really all you're taking is you're taking two functions and you're evaluating one at the other. So, new notation. F composed with G. Take note, this is different than f times g, which we did last week. That's a function operation. This is f composed with g. And the rule is, if you want to do f composed with g, you evaluate the function f at g. You really just take the function g and stick it into f, that's your input. Okay? And similarly, we have g composed with f. If you want g composed with f, you evaluate the function g at f. Okay? That is g composed with f. Okay? I like to do little domain and range clouds. So this one here, we're going to do f composed with g. We're starting with g here. This is where we start. And so we have the domain of g, and we have x's in there, and when we act on them with g, we get g of x's. This is the range of g. But now we are going to take the outputs of g and stick them into f, so this is also going to be the domain of f. And when we act on things that are in that world with f, we get things that look like f of g of x. This is the range of f. And it is also the range of f composed with g. So when we do this f composed with g, this is doing it one at a time. We take an x and we evaluate it at g. And then we come in, we stick the g back in there, and we get another f. If we do them all at the same time, then we skip the middle guy, so to say, and this is the new rule for f composed with g. Okay? We say that number x is in the domain of f composed with g. Okay, x is in the domain of f composed with g. The domain of f composed with g is all x in the domain of g such that g of x is in the domain of f. Right? I'll say it again. The domain of f composed with g is all x in the domain of g such that g of x is in the domain of f. Right? We don't want to get anything in here that's going to give us problems with f. On this assignment, I don't want you to worry about domain and range, even though it's going to say so. Let's not worry about that. Let's just worry about the algebra of what we're doing today. So, two functions. F of x equal to 2x minus 5, g of x equal to 4 over x. We are going to find f composed with g and g composed with f. Okay. F composed with g, the rule says evaluate f at g. So g is my input. G is 4x. Remember, f is just saying whatever you give me, I'm putting it there. I'm going to multiply it by 2, then subtract 5. So we have 2 times x, which is our input now is 4x, minus 5, and 8x minus 5 is the function f composed with g. G composed with f, we are going to do it the reverse way, so to say. We are going to evaluate g at f is 2x minus 5. So that's our input now into the function g. So we have, g, by the way, says whatever you give me, I'm going to multiply 4. So 4 times 2x minus 5, and we have 8x minus 20 is g composed with f. So they're not the same. F composed with g and g composed with f. I hope you see that. And that's one thing that we want to make sure of every time we run into new operations. So you had plus, right? And you knew in third grade or kindergarten that 2 plus 3 is the same as 3 plus 2. You knew that. And when they introduced subtraction to you, though, you said, wait a minute, 3 minus 2 is not the same as 2 minus 3. Right? And we have to pay attention to those kind of things as we learn new tools and become more sophisticated. So note here that f composed with g of x does not equal g composed with f of x. They're not, the function composition is not commutative. And so file that away in the bank. Yeah. F composed with g and g composed with f. One more. Let's make sure that we have our board all the way, our thing all the way over here. You need to see more. See, I almost did a whole one where you couldn't see. So similar. Sometimes one of these ends up being similar or easier than the others. So for instance, f composed with g. I'm going to skip a step here. I'm just going to go right to f of x squared plus 3x minus 10. Right? F composed with g says evaluate f at g. So I take g, and now that's my input into f, and I have x squared plus 3x minus 10 plus 4. X squared plus 3x minus 6. That is the new function f composed with g. G composed with f's a little more involved, as you will see. G composed with f is g evaluated at f, So now x plus 4 is their input. See where the inputs go. They have to do a couple things here. X plus 4 squared. X plus 4 squared plus 3 times x plus 4 minus 10. So this is a FOIL. Remember, this is not equal to x squared plus 16. It is x plus 4 times x plus 4, or x squared plus 8x plus 16 plus 3x plus 12 minus 10. Collect like terms, we have x squared plus 11x plus 18. And that is the new function g composed with that. I have said, don't worry about the domain and range for these. And I will give you some problems to work on. Let me know if you need any help with them. It is really just pretty much algebra at this point. Love you guys. We'll see you later.